In this session, I will first introduce interdisciplinarity of applied machine learning in STEM education. And then, like in the test mining lab, we'll build a very simple machine learning model together. Okay, nice picture here. And before I introduce the applied machine learning in STEM ed, I want us to think about what machine learning is. So in machine learning, first, we need a large data set, and I would say at least 1,000 data points. And this data set should have informative features so that patterns could be learned by machine learning algorithms. And then the model uses these learned patterns to make predictions. And choosing informative features is a critical step for building any machine learning models. For instance, in this picture on the right side, 3 dots is not informative enough to differentiate the Chihuahua and the Muffin. Adding context such as 3 dots in a pet store might be more likely make the right prediction will be Chihuahua. Similarly, in education, if you want to predict the engagement level of students in a math classroom, we need to know what kinds of features would be informative for the prediction task. The way teachers interact with students might be one good feature, and there are many more. So that is to say, to summarize, again, re-emphasize the point, machine learning is not magic at all. It's about automatically finding meaningful patterns in data. And the key of building machine learning models is finding informative features, and finding informative features relies on in-depth understanding of the application area, like in education. And this tells us that machine learning is an interdisciplinary area, and domain knowledge or the understanding of the application area plays a significant role in building any machine learning model. And it's you who bring domain expertise in this area. And that's why in many projects, we see interdisciplinary teams working on the application of machine learning in STEM education. Like this one from NC State, multimodal trajectory analysis of with engagement with interactive science museum exhibits. And this article is about finding engagement patterns of museum visitors with multimodal data, such as eye gaze and facial expression. And there are many other studies that have explored finding patterns about engagement, identity, self-efficacy, motivation, knowledge gain, misconception in science, and so on. So those are like really trending topics in machine learning area. And next, I will briefly introduce a landscape of study that use machine learning in STEM ed, and then conclude with affordances and limitations of machine learning. Machine learning is, as I just mentioned, there are many training topics in this area and has been applied in learning contexts for all grade levels. And a large portion of literature focused on science and math education. And one example is this year's special issue in Journal of Science Education Technology. This issue focused on applying machine learning in science assessment. In addition, Alonso Fernando and the colleagues reviewed the literature for applications to game learning analytics data, and the authors demonstrated that raw GLA data can predict impact on learning, recommended creating student profiles and the clusters. And based on such profiles and clusters, instructors or teachers can provide targeted feedback and adaptive learning experiences. And they also show that serious games can be designed for computational assessment using machine learning. And another review study, Ruan and Sai, reviewed the literature for applications of ML for precision education. And this review study showed that the majority of studies focused on the prediction of learning performance or dropouts, and were carried out in online or blended learning environments among university students majoring in computer science or STEM. And furthermore, Bergeron and Wang Davier highlighted the trend of modeling the process as learning outcomes with learning analytics in the review of NAEP's use of learning process data. So those are the review studies. And within machine learning, there are 2 basic approaches, unsupervised learning and supervised learning. And the main distinction between these 2 approaches is the use of labeled data sets. And to put it simply, supervised learning uses labor input output data, and while unsupervised learning does not. Specifically, for unsupervised learning, it uses machine learning algorithms to analyze or cluster unlabeled data sets. And for instance, in one study, our group used a clustering algorithm to identify students' navigation patterns in AR, augmented reality science labs with log data of students' processes of conducting science experiments. And the supervised learning is a machine learning approach that's defined by its use of labeled data sets. And these data sets are designed to train or supervise the algorithms into classifying data or predicting outcomes accurately. For example, Sampedro and colleagues used logistic regression to predict the students' STEM and non-STEM college major enrollment with log data of students' processes or using assessments. It's a mass education technology. And the data is labeled as whether students chose STEM major or not. And this paper shows that a combination of features of student engagement and student success in assessments can distinguish whether student will take STEM major or not. And later, we will replicate the experiment in this paper to build a logistic regression model to predict whether student will choose STEM major or not. And in addition to using machine learning as a methodology to find patterns in data and making predictions based on such patterns, there is another field, K-12 AI education, artificial intelligence education, is exploring different ways to teach machine learning for K-12 kids, so that they are well prepared to reason how computers make decisions and the impacts of AI in their life and their future careers. For instance, the work from my group focused on teaching high school students to model unstructured data as it's a foundational practice in building machine learning models as a subfield of AI. And this project, Project StoryQ, integrates the learning of math, language arts, and the computing. And it has the potential of helping students understand the role of human or the role of AI developers in building these models. And as shown in these studies, students can benefit from understanding machine learning as it's growing in prominence in a variety of ways that ultimately impact their lives. And these systems can also be designed using machine learning to provide customizable experiences for learners. And teachers may benefit from ML related to better organization of content, curriculum, and teaching strategies, as well as automatic scoring of student-generated text as a part of a complex open-ended assessments. I think some of you also mentioned that in the text mining session. And also researchers can benefit by using machine learning to analyze patterns in data or to make predictions on outcomes based on variables related to important characteristics. But there are also limitations of machine learning, including like ethical considerations such as the issue of bias and discrimination, because it's got patterns in the data. And if it's a pattern that's like way it shows the structure bias, then you will show that way. And you should be careful using those patterns. And there are also deterministic problems such as machine learning research simulations are computationally expensive, especially on large training data sets. And if it's like a large data set with a complex model, it might take weeks for you to run just one model. And the issue of lack of data or good data in some fields such as literacy education and also data about student learning for marginalized students. And then the interpretability of how algorithm reached its conclusion also is a challenge to rely on the aggregate pattern from machine learning to understand learning in context, such as studying nuanced changes in individual students' interaction with learning environments. That is to say, there are times when using machine learning is just unnecessary, does not make sense, and sometimes may get you to difficulties. So it's not magic, and also be cautious when you use it. So in conclusion, machine learning is a current hot topic and it continues to grow in popularity based on its applications in education. And it can benefit all key stakeholders in K-12 STEM education, like students, teachers, researchers, in addition to parents, administrators. And the major limitations will continue to exist and need to be attended to when conducting research or applying machine learning in STEM ed. And numerous opportunities exist for continued research and development in STEM ed at all grade levels. And next, let's do some hands-on activity while replicating the experiment that I mentioned earlier.